Hello, this is Patrick from Royas, and today I'll be teaching you how to play MIDI files and trigger sound font notes in Godot. Now let's get started. First thing you'll need to do is go to the link I have in the description for the MIDI sample provider.cs. You're going to copy all this code and put it into a Godot C# script like I've got here. Okay, to start, all we've got here is a node with a MIDI controller.cs attached to it, and a MIDI controller.cs script, and a MIDI sample provider.cs script. That this one was provided to us via the MeltySynth GitHub. So I'll show you where I got that later. We'll be editing this, so there's already some code in there, whereas this one we'll write entirely ourselves. Okay, let's open this up. Now the first thing we need to do is add a couple .NET packages. So we'll go .NET in the console here and go add package NAudio. And then when that's done, we'll go .NET add package MeltySynth. There, and now we've got both of the things that we'll need to get going on this project. All right, so now what we want to do is go and get the list of the audio devices and pick which one we want to play the sound through. So to do that, we go using system.collections.generic, and then we want to get a list, and then we'll get an device, which adds this NAudio core audio API. And then we will call these devices. And then that's all we need to do there. And then we will do another device. And we'll call this selected device. And then this one will be the one that we use. So to get the list of the devices, all we got to do is go and make a function. We will call this private void get audio endpoints. Actually, what I'm going to do is I'm going to return the list of devices. Okay, now I'm going to do an device enumerator, and then I'm going to say new device enumerator, and then we'll return the enumerator dot enumerate audio endpoints, and then we'll go data flow dot render and device state dot active, and then we'll go dot to list, and that'll get us our audio endpoints. So when ready, we'll call this function, and we'll go devices is equal to get audio endpoints. Then we'll loop through these devices. So for each device, so we'll go devices.count, and then we will type gd.print. And then we will go, so we'll use the number, and this is how we'll select which device we want is by typing in the number. And then we'll just put the devices dot or I dot friendly name. And that'll give us a list of all the active audio devices that we can play through right now. So I'm just going to run this. And if I move this up, you can see that I've got my speakers here at position 0, or my headset. So I'm going to close that, and we'll go back to the code, and we'll check the input to select the device. So we'll go public override void underscore input. Then we'll go if selected device doesn't equal null. So like if we have a device, we're not going to check for input to set it. We'll return. Then we'll go if at event is input event key and event key dot is pressed, then we will try and parse this event key into a number, and then we'll use that number to select. So we'll have to go and make our own parser. So to do that, we'll go private bool try parse event key to number. Then we will set this to be, or we'll set the parameters to be input. We'll set the parameters to be input event key, and then we will have an out int number. String key code is equal to event key dot key code dot toString. Then we'll set number to equal -1. So that's if it fails, it'll stay as -1. Then we'll go if key code dot length is less than 3, we'll return false. Then we'll go if not int dot try parse key code. And then we'll go 3, because that's where the number will be in if it is a number key that is pressed. So it'll be key code 3 dot toString. Then we'll go out number. So if not, we will return false. Then if that succeeds, we'll return true. So we've got our parser. Now all we got to do is go if try parse event key to number, and then we'll pass in the event key, and then we'll say out int number. So if this works, then we'll go and take these devices, the number that we selected, and select the device. So we'll make another function for that. So we'll go private device select endpoint. Then we'll go int. Actually, I'm going to rename this device. Int select device int index. And then we'll go if index is less than 0, or if index is greater than or equal to devices.count, will return null. Then we'll return. So if that's not true, if neither of those conditions are true, we'll return devices and then index. So here we'll go selected device is equal to select device number. Perfect. That'll select our audio device. And now we can actually try and play sound through it. In order to do that, we'll need to go up here and make a couple more variables. So the first one, we'll make a private wasapi out. And then we'll call this wave out. And then we'll make another private MIDI sample provider. And we'll call this player. Then we'll scroll back down here and we'll change this to be not the, if it can't parse it, then we'll return. So then we can go if selected device once again is equal to null, we'll return. Here, I forgot to assign the player, so we'll go and do that in ready. So then we'll go player is equal to new MIDI sample provider. And we'll go project settings dot globalize path. We'll go res : // that'll just be our editor path, and then whatever the name of your sound font is. So mine is called Famicom.sf2. If you look over here, I've got it right here in my project folder. I've also got a MIDI file as well, but the MIDI file doesn't show up in Godot. So you'll just have to trust that it's there. I'm going to save that, scroll back down to here. I'm going to type wave out is equal to new wasapi out selected device audio share mode shared true, and then I am going to set this to let's say 20 because that's the desired latency in milliseconds as the tooltip said there. So then I'm going to go wave out dot init, and then I'm going to pass in the player that we just assigned in the ready, and I'm going to go wave out dot play. So now it can start putting out noise. Now we're going to try and send a MIDI file to it, so it'll just play the music from a MIDI file for us. To do that, I'll just go private void play MIDI file. And I'm going to say string path. And then I'm going to say file stream fs is equal to new file stream. Then I'm going to go project settings again, dot globalize path. Since I've still got this in the same folder, I'm going to go res : res : and then I am going to append the name, which is quite long for this one, so I'm just going to copy it. And then I'm going to go file mode dot open. Now I'm going to go MeltySynth dot MIDI file. MIDI file is equal to new MeltySynth MIDI file. And then I'm going to pass in the file stream, and that'll create the file, or that'll load the file for us. Now I'll go player dot play MIDI file, and then I'm going to turn looping on to true. So now I'm going to go and build this, and we'll see how it works. I forgot to play call the play MIDI file. So I'm going to go play MIDI file. Oh wait, I don't even need the path. I'm calling it in here. I'm just going to switch this out, move this to here, and then I'm going to put the path in here. Now it should work. So I'm going to go back into Godot. I'm going to move this up and select my headphones. As you can hear, it started playing the MIDI file. So I'm going to go back to my code, and now we're going to look at how to trigger individual notes. So I'm just going to comment this out so we don't start playing immediately a song. Okay, to trigger individual notes ourselves, we'll have to go and edit this MIDI sample provider file that was made by Melty. So to do that, we'll need to make a few functions in here. The first one we'll put here, and we'll call this a public void play note. And then we'll take in an integer, and that'll be the note. So it'll be like the MIDI number. And we'll take an int for the channel that the note will be playing on. And then we'll go another int for the velocity. Okay, and then we'll make another one just below this, and we'll go public void stop note, and this will be an int for the note and an int for the channel. Perfect. Now for this play note, all we got to do is go synthesizer dot note on, and then we'll pass in our channel, our note, and our velocity. And for stopping the note, it'll be pretty much the same thing. So synthesizer dot note off. Then we'll pass in the channel and then the note, and that'll stop our notes from playing. We'll make another function down here, and this will be a public void render wave. And what this will do is, I'm actually not totally sure why this is needed, but like in all my tests, I've needed this to synthesize individual notes. So I'll go float and then make that an array. We'll call this left, and that'll equal a new float array. And then we will say, let's go with the wave, or no, it's the format dot sample rate. And then we'll go float right as well. So this is the left and right here, I assume, is equal to new float format dot sample rate. Then what we got to do is go synthesizer dot render and left, right. So we'll only want to call this once, because if we call it more than that, it can actually kind of just crash the whole thing and it'll stop working. Okay, now let's go back to our MIDI controller, and we will make a couple more variables at the top. Those will be a private float time since last note will be 0f. Then we'll make a private int last note is equal to 0. We'll do a private bool render wave, and that will be not lowercase render wave, and that will be equal to true. So now we'll go into process here, and so we'll say if the device, selected device, is equal to null, we'll return. So we don't want to play music unless we've got a device that's selected, which makes sense. Then if we do have that, we'll go if render wave, and then we will go player dot render wave, and we will set the render wave to false because you only want to do that once. Now we'll go time since last note is plus equals to delta. No, not delegate, delta. And then we'll cast the delta into a float. Then we'll say if time since last note is less than 1 second, we'll return. Now here we'll say time since last note is equal to 0f. Then we'll say player dot note, stop note last note, and then let's just say channel 0. We'll stick to channel 0 for this. Then we can go last note is equal to gd dot rand range. And so MIDI, the keyboard range for MIDI notes is 21 to 108. These are the numbers for the keyboard range. You can go higher and lower than that, but like a lot of sound fonts won't have sounds that will match all these, so you'll just get a silent note. Your own sound font will vary, and you'll have to know where it is for each thing, but that's a general good rule of thumb is to stick within this range. Then you can go gd.print, and I'm going to say plain note, colon, and then last note. Now I'm going to go player.play note, and I'm going to play on the last note, and then the channel will be 0 once again, and I'll set the velocity to 100. So the velocity is how hard you're hitting the note. So some sound fonts will have it so that if you set your velocity high, it'll sound like you're really hitting the key. You're really hitting the key or plucking the string really hard. And like if you put it really low, it'll be as if you did it really quietly. So it'll play different sounds based on your sound font. Okay, so let's go into Godot and run it. I'm gonna move this up again, press 0 to select. Beautiful. Best song ever made. So it's not gonna sound good, but like that's up to you if you want to make it sound better yourself. Now, each sound fonts actually have a few things. So one, that was loud, so I want to turn it down. So I'll show you how to turn it down right now. So you got to go into this MIDI sample provider.cs, and I'm just going to add this line sequencer dot synthesizer dot master volume, and I'll turn that down to 0.1 F. Perfect. That's going to be a lot quieter. So I guess we'll just go and test that. I'm going to press 0 for my headset. It's quieter, still very beautiful. Perfect. Now, we may want to know how to do some instrument changes. So, to change the instrument within your sound font file, we'll go synthesizer dot synthesizer or synthesizer dot process MIDI message. Then we'll say 0 because that's the channel we want to set it on, and that's the channel we're using. And then this is going to be a little bit weird, but we're going to go 0 X capital C 0. So these are the types of MIDI messages. Like these are defined in the MIDI protocol, what these are going to mean. And so this means instrument change. I'll link a document in the description, and I'll pin a comment with a link to a document that gives you information on all these messages. And then I'll also link some sites where you can get some MIDI files to test and some sound font files as well. Then I'm just going to change the instrument to 3. And with this code, this second variable, it's kind of a throwaway. You can set this to whatever, and it's not going to really matter. So I'm going to go back to Godot, and I'm going to hit play. Hitting 0, and it's quiet. Too quiet. Okay, I'm going to go back. Maybe I've got the volume too low. I'm going to set this back up to 1. Go back to Godot. There we go. Yeah, it was too quiet. But those are different sound, equally as beautiful and gorgeous as the previous ones. Now, this isn't going to work for a MIDI file that you pass in because the MIDI file is going to handle each channel and what instrument it plays. So if you want to change the sound for the MIDI files, you can go sequencer dot on send message is equal to synthesizer, comma, channel, comma, command, data 1, data 2. And then you'll do this arrow. And in here, we'll say if the command, so this is what we are sending here, is equal to 0xc0, once again, then we'll say data 1 is equal to 3. So like, as you can see, data 1 kind of matches this spot here. So it's basically, we're just doing this, and then we need to go synthesizer dot process MIDI message like we did before, channel, then command, data 1, and data 2. So this will intercept any instrument changes that the MIDI file tries to send, and it'll change it to the third instrument. So I'm going to go back to this file, and I'm just going to say return, so it's not going to play an individual note. I'm going to uncomment this file, and we'll be able to hear that. Okay, go back to Godot, hit play. Sounds totally different. Perfect. Awesome. Thank you very much. Hope you found this helpful, and I would love to hear what you think you could use this for. Bye.